We're now going to continue with the measurement section, but we're going to look at the spectrum measurements. So we're going to be using the same signal that we used in the scope YT mode, which is a 16 megahertz clock, but we're going to make some measurements in the spectrum display. So I'll change the acquisition to spectrum, and now we're in a spectrum display where we're displaying amplitude against frequency. So in this particular display we're going from DC up to 10 megahertz. It is possible to increase the bandwidth up to 350 megahertz, so now we're displaying up to 350 megahertz, which is the full analog bandwidth of the instrument. For my particular signal I'm going to select 78 megahertz, so I can look at the fundamental and the third harmonic. So we could measure the frequency manually with a cursor. Now we can just position a manual cursor on a component and measure directly the frequency. So here we see the 16 megahertz fundamental, but in the spectrum mode now we can go and look at the next largest component, which will be the third harmonic, and measure the frequency of the third harmonic, which will be 48 megahertz. So it's possible to measure a lot more of the frequency content of a signal in the spectrum display. We can perform these sort of measurements automatically by again using the measurements facility. So in the measurements now we have the spectrum measurements, so we're measuring frequencies, average amplitude power, total power, harmonic distortion, spurious free dynamic range, synad measurements, signal to noise, and intermod distortions. So if we wanted to measure the frequency again of this particular signal, measure it at the ruler, say. Okay. So here now we're doing an automatic measurement of the fundamental frequency, the 16 megahertz. Similarly, we can do amplitude type measurements. So we could again use a cursor to make a measurement on the amplitude. And I'll put a second cursor onto the third harmonic there. So we're seeing that the fundamental had an amplitude of minus 11 dB micro, or the third harmonic was down at minus 24. So we're seeing a difference of minus of 12 dB. In the options menu, we can actually change the units of the vertical display. So I'm going to change them here to dBm. So now we're measuring in dBms. So again, we're measuring directly in dBm. It is possible again to use a measurement to measure this difference in amplitude directly. So again, we select the measurements. So here we see all the different measurements available. So we're going to select for this second measurement the spurious free dynamic range. I'll select it across the whole trace and say OK. So now I'll delete the first measurement. So now we're measuring the difference. It's automatically found the fundamental at minus 12 and then looked for the next highest component, which indeed will be the third harmonic, which we know should be 12 dBs below it. And if we look at the measurement, in fact it has measured automatically the 12 dB. So it's automatically looking for all the spurious components below the fundamental. Finally, under the when we add measurements, there are more options available under the advanced menu. So we can actually apply filters to the stats measurements, and if we're doing any harmonic type measurements, we can actually select which harmonics we do measurements over.